Hi students, in this video we are going to learn some of the basic properties of matter. You already know matter is nothing but anything that occupies space and has some mass. Every matter is made up of smallest and finest particles are called atoms. These atoms combine to form molecules. Depending upon the intermolecular distance, we categorized the substances as 5 types: solids, liquids, gases, plasma, and BEC, Bose, Einstein, condensate. So totally 5 categories are there. Among those particles, some of the basic properties are there. To learn those basic properties, we are going to perform some of the activities in this video. The first activity is the activity that prove liquids have no fixed shape. There is no shape for the liquids, but they have a fixed volume. Let us do that activity now. Students, see now. The activity what we are going to perform is, for that activity we have a beaker, round bottomed flask, gas collecting jar, it's called measuring jar, conical flask, and a water bottle with water. Right. For that purpose what we are going to do is, first of all I am going to measure 100 ml of the water. I am going to take 100 ml of the water. See, we can observe clearly if you pour the water level up to 100 ml. Now I taken 100 ml of the water in a beaker. What is the volume now? The volume is 100 ml. What is the shape now? It look like as a beaker. Now transfer this same 100 ml of the water into the round bottomed flask. How much quantity I transferred? Answer is 100 ml. What is the shape of water now? It look like as a round one, means look like as a round bottomed flask. How the flask is there? It look like in that shape. Once again, transfer this 100 ml of that water into the gas collecting jar. Okay. What is the volume now? Volume is nothing but 100 ml only. What is the shape now? It look like as a cylinder. Why? Because the gas collecting jar is there in the shape of a cylinder. It is there in the form of a beaker. It is there in the form of a round bottomed flask. It is there in the shape of a cylinder. Volume is the same. Now transfer this 100 ml into the measuring jar. Yes. Here you can observe, here the volume is how much? 100 ml in a clear manner. This means volume is not at all changing, but there is a change in the shape. Now once again transfer this 100 ml of the water into the beaker, into the conical flask. Yes. See here, volume is same. Volume, though you changed the 100 ml of the liquid into the different vessels, the volume is not at all changing, but the shape is changing. This means from this activity we can say that liquids does not have a fixed shape. They look like as the shape of the container, but they have a fixed volume. Once again, liquids and at the same time gases also does not have a fixed shape. They look like as the shape of container. They have a fixed volume. Students, we already learned that every matter is made up of particles and how the smallest the particles may be. Now in this activity we are going to learn what is the size of those particles of the matter. Size means generally it may be big one or small one or very small one. Tiny particles. We can't see them, but the particles are there. This means sometimes we require a microscope. For example, say if it is a bio-living organisms, we require a microscope. Sometimes we require an electron microscope also. That means particles are there, but we can't see those particles with naked eye. Sometimes we can see with naked eye, sometimes we can't see with naked eye. To do that activity or to prove the size of the particles, let us perform one of the activity now. Students, now we are going to perform one more activity. In that activity, I have taken a beaker, glass beaker, with the gradients are there 50, 100, 150, 200. This is nothing but volume we are going to consider. This means, for example, if you pour the water up to the level of 100, this is nothing but 100 ml. And if you pour the water up to 150, that is called 150 ml. Up to pour the reading, that is 200 ml, that is. Now, you already know this. Any expectations are there? The expectations are nothing but it is a simple table salt, sodium chloride, what we are using in our regular life. This is called spatula, a glass stirrer, and some quantity of water is there with us. Simple experiment in this, nothing is there. Now see here, I am going to pour some water into this. For example, I am going to take the water up to 200 ml. 200 ml of the water I consider. Now the water level is how much? 200 ml of the water I consider. I taken 200 ml of the water. Right. Now, to about some amount of the salt I am going to add to this. Shall I add salt? Yes. I added some quantity of the salt. How much salt is there? That I don't know. Approximately 10 grams. Now stir this. Yes, by going on complete stirring, the total salt is dissolved in the water. Now say how much volume is there? The volume is not changed, that is 200 ml only. I added about 10 grams of the water, but there is no change in the volume, that is 10 grams only. Once again add some amount of the water, some amount of the salt to this. Yes. Once again stir this. Still the salt should dissolve in the water. No salt should left. No salt should left. Completely stir into the water. Yes, salt is completely dissolved in the water. Now once again observe this. The volume is 200 ml only. There is no change in the volume. Before we added about 10 grams of the water, there is no change in the volume. Again 10 more grams of the water, means totally I added 20 grams of the water, but there is no change in the volume. No. Once again I am going to add some more pinch of the salt. Once again to the process of stirring. Complete stirring is required. Complete stirring is required. If you are going on stirring, what happens? Salt is dissolved in the water. Salt dissolved in the water. Our expectation is, as the salt is dissolved in the water, the volume should rise. Why? Because before 200 ml, we added till now 30 grams of the salt. Now it should become more than 200, but the volume level is 200 only. Once again, we add 10 more grams. If we are going on adding about 10 more grams of the salt, then our expectation should be it's up to 250 ml. Why? Because 200 ml of the water and 50 grams of the salt we added till now. So our expectation should be more than 250, but the level indicating is 200. What the thing is happening here? Though you are adding the salt is dissolved in the water. Any expectations are there? Now, from this, we can understand that there is certain gap is there in between the particles of the liquid. some space is there between the particles of the liquid or otherwise the molecules of the liquid. That space is called intermolecular space. The distance between the particles of a given solid or liquid or gas is called interparticle space. Salt, what we added, is mixed in between the particles of the water. So further the volume is not changed. From this activity we can say that there are certain gaps, certain distance is there between the particles of any kind of matter, either it is liquid or solid or gas. This space is called intermolecular distance. The definition of intermolecular distance is the distance between the two successive particles or two successive molecules of either solid or liquid or gas is called as intermolecular distance. This intermolecular distance is very least in solids, a little bit more in liquids. The intermolecular distance is too large in the case of gases. Let us do one more activity to study the property of liquids. Students, till now we learned that various properties of the particles of the matter, though they are naked to the eye or unable to see through the naked eye. In this activity we are going to know what is the space between the particles of matter. Why? Because matter, either it is solid, liquid or gas, whatever it may be, these are all made up of the molecules. Simply we are calling as particles. How much gap is there between the particles of the matter, that we are going to study now. This distance is called intermolecular distance. The distance between the two successive particles of any kind of the matter is called intermolecular distance. After this activity we will come to know that the intermolecular space is very less in solids. The intermolecular space is a little bit more in liquids. It's very high in the case of gases. For that purpose we require a glass beaker, water, potassium permanganate, stirrer, and those are all. Let us do the activity now. Let us perform one more activity. See, for that activity purpose I taken beaker 1, beaker 2, beaker 3, a conical flask, glass stirrer, dropper, spatula, potassium permanganate KMNO4, potassium permanganate with chemical formula KMNO4, and some quantity of water in a bottle. For the activity purpose I am going to take about 100 ml of the water. Yes, now the quantity is nothing but 100 ml of the water. Into that 100 ml of the water I am going to add a pinch of potassium permanganate. Potassium permanganate. See the color of the potassium permanganate. Can you guess what's the color? It's nothing but violet in color. Now see the liquid, how it is changed. It is changed into purely violet in color. Still this clearly, very good. Now we can say that clearly the solution is dissolved. Potassium permanganate is dissolved in that. Now I am going to take a few ml of the solution, about 10 ml of the solution I am going to take. I am going to drop the 10 ml of the solution into the second beaker. Now in the second beaker how much solution is there? Just only 10 ml. Now I am going to add 90 ml of the water to this. How can we say 90 ml? Already 10 ml is there, and again I added more than 90, then automatically the total solution becomes 100 ml of the solution. See here, there is a change in the color. The color is diluted, but the color is not at all removed, but the color is simply diluted. From this, you take again 10 ml of the solution, and again I am going to transfer that into the 10 more. Now, in this third beaker, how much solution is there now? 10 ml of the solution is there. Once again, make it 100 by adding 90 ml of the water. See here, there is a change in the color, but the particles are look like that only. From this, once again, you can take 10 ml of the solution, transfer into the conical flask, again add 90 ml of the water. So what happens? You are going to make the solution of 100 ml. Now see, in this also light yellow color particles we can observe. What does it mean? Of course, it look like as clearly white in color, but particles will be there in that. Even in this solution also particles are there. In this solution also particles are there. In this solution also particles are there. Even in the final solution also particles are there. Though you are changing the solution from beaker 1 to beaker 2, beaker 2 to beaker 3, 3 to 4, color gradually decreasing, but the color is existed. What does it mean? Between the particles, more space is there, and we can't see those particles. So, from this activity, we can understand that all the particles are very small. This means they are very tiny, smallest particles. We can't see those particles, but the particles are existed from this. Why? Because though there is a difference in the volumes, the particle color does not change. The particles are existed in that, but we can't see those particles. Let us do one more activity, whether the distance is there in between the particles or not, that is intermolecular force of attraction. Students, till now we did many activities to learn the properties of different kinds of the matter. In this activity, we are going to prove the evidence, means proof for the force of attraction between the particles of matter. Force of attraction between the particles of matter. Matter means either it is solid or liquid or gas. General means we are going to study the how about the force of attraction between the particles of solid. How about the force of attraction between the particles of liquid? How about the force of attraction between the particles of gas? For that purpose, we may have a small activity. To do the activity, first of all, I taken an iron nail. I think you saw this is an iron nail. Now, I am going to apply certain amount of the force on this iron nail with my finger. See now, I am applying more large quantity of the force on this. Is there any change is there in this? No. There is no change in the shape of this iron nail. Now let us consider this is a chalk piece. You already know. If I apply certain amount of the force, what happened? That chalk piece is break. Of course, chalk piece is also a solid, and at the same time, nail is also a solid. And then, if we consider there is a tap, from the tap, water is flowing. If you cut the water, what happens? We can stop the water for certain time, but water flow does not stop. Means there is a continuous flow of water. If you observe some solids, because solid is also a case of matter. In certain solids, they are not at all breaking by applying a small quantity of the force. This means there is a great force of attraction, large force of attraction is there among the particles of that solid. Chalk piece is also a solid, but the force of attraction is weak. Liquid, that is water, is also force of attraction is there among the particles, but those force of attractions are a little bit less when compared to the force of attraction among the solids. You know that already the force of attraction between the gaseous particles are very less. Why these forces are more? If you consider in the case of the solids, the molecules are arranged like this. If you consider per unit volume, the molecules are arranged very close in manner. These are all the particles that is there in the case of liquid, solid. If you consider in the case of the liquid, the particles are at a little bit distance is there. Now this is there in the form of a liquid. If we move on to the gas, the particles are too long. This means the force of attraction among those gaseous particles are very less. So from this activity, we can say that the force of attraction between the particles of matter, that is solid, liquid and as well as gas. The force of attraction between the particles of matter, that is solid, is too high. The force of attraction between the particles of matter, that is liquid, is moderate. The force of attraction between the particles of matter, that matter is nothing but the gas, is very less. From these activities, we can understand various properties of the particles of the matter.